Hey, good morning.
Hello.
Welcome. We haven't done a core storage session for some time. We were wondering if there was going to be much interest. I think that question has been answered. Yeah. So we're going to deep dive into core storage in vSphere 6.5. So we did a whole bunch of stuff, VMFS 6, some enhancements to VAAI, and a few other things that we'll talk about with you. But yeah, needless to say, that's what we're going to be doing this morning. If this thing is, there we go. So we have to put up this disclaimer. You're going to see this a lot during the week. I'm not going to be talking about anything really future-looking. I don't think you're going to be talking about
maybe
anything
I'll make something up. I don't know.
There you go. So by way of introduction, my name is Cormac Hogan. I work in the Storage and Availability Business Unit at VMware. Do a bit of blogging from time to time. Cody?
My name is Cody Hosterman. I work for Pure Storage. I do a little bit of blogging too. And Cormac's people reach out to me. They're like, all right, we want someone to co-present with him, but his picture has to be more embarrassing than Cormac's. So I think we got there. So, and I have to compliment his hair at least twice. So I made all that up.
Yeah. And that's what they do with Pure Storage every day. So it looks like a great place to work.
Hey, you know.
I'm going to get it back, don't worry. So this is what we're going to talk about. Cody's going to kick it off. We're going to talk about the new limits that we introduced in vSphere 6.5. I'll come back in then and I'll talk about what we've done with VMFS 6, how we've improved upon the previous versions of VMFS. Cody will come back in. He'll do VAAI, or array integration primitives. So we've done a bunch of work around UNMAP. And we've done a bunch of work around atomic test and set as well, the ATS primitive, which is the locking primitive. I'm going to come back in then and talk about SPBM. So SPBM is the storage policy-based management. But what I'm going to be talking about is the I/O filter mechanism. I don't know if many of you have come across that, but in 6.5 we have two I/O filters that are included. They're basically ways of plugging into the I/O path of VMs. I'm going to talk a little bit about what we've done there. Talk about some of the improvements we've done with NFS 4.1, a few minor improvements around iSCSI, and then Cody is going to close off with NVMe. Sounds good? All right, so.
All righty. All right, so let's get into it. So storage limits. Out of curiosity, how many people are running 6.5 or looking to move to 6.5 in the next 6 months? That's wonderful to see. Awesome. All right, so scaling limits. So many of you are probably very aware, right, that previously ESX supported up to 256 devices and 1,024 logical paths. That has been doubled in 6.5. Right, so you have a lot more logical paths, a lot more devices. So that should help quite a bit. Most people ran into the pathing limit, generally I'd see, more than device limits, but both of those have been doubled, which is great. One thing to note though, right, you're still limited to 256 devices from a single target, right, because the way that VMware does its LUN addressing kind of limits it there. But that limit does not apply to virtual volumes, right? So you can still have up to 16,383 vVols per protocol endpoint. Add another PE, then, you know, a lot of vVols. Another one here, 512E support for VMFS 6. If you have an array that supports the 4K sector size, right, VMware now supports that. You'll see this listed inside of VMware as kind of 512 emulated, right? They do an emulation around it. So this is now supported for VMFS and, of course, raw device mappings. Main thing here, you'll see some differences if you do kind of a core device capacity list. Probably really the main thing that you'll notice about it is that if your storage is formatted with 512 sector size, it's going to default to VMFS 5. Like if you do like a boot from SAN, it has it automatically install VMFS, it's going to use 5. If you're using 4K or 512E, it's going to default to VMFS 6. And I believe that's might be changing, but I said we're not talking about the future things, I guess.
Yeah. I mean, eventually coming down the line, we will be doing 4K native devices, at some point.
So that's really the main change around that, and probably the one thing that you'll notice if you do see some of it. I know there was a Reddit subreddit about this a while back. So another thing too, so disk schedule number requests outstanding. This has changed how it gets managed. Previously, so if you're not familiar, DSNRO is essentially a hypervisor level queue depth limit, saying how many outstanding IOs you can have sent to a volume at once. Previously, this maxed out to 256. They have changed this behavior in 6.5, and I think it's a great change. So now it's limited to what the HBA device queue depth limit is. Because if you're not familiar how VMware kind of calculates its queue limits, is that the minimum of those two, DSNRO and the HBA device queue depth limit, is your actual effective queue depth limit, right? And if there's more than one VM running, which is generally the case, right? If there's more than one VM running, it's going to default to the minimum, which is usually going to be DSNRO. So changing DSNRO larger than the device queue depth limit on the HBA didn't really make a lot of sense. Or if it was really high, you were limited once again to DSNRO. So in 6.5, the maximum for DSNRO is whatever the current HBA device queue depth limit is set to. So if it's set to 2, well, there's your limit. If it's set to 2,000, well, there's your limit. Right? So that's a nice change and allows you to push a lot more performance, a lot more concurrency to a single volume from a single host. All right.
Cool.
VMFS
Thanks.
6.
So I apologize, I should have asked it to start. Can everyone understand Cody okay? Because he's got a bit of a funny accent. All right. So VMFS 6, let's get cracking on that. Okay, so the first thing with VMFS 6 is we have these new internal file block sizes or formats. And these are nothing to do with the VMFS file block itself. That's still 1 meg on VMFS 6. This is all about creating files. So if you're creating small files or very small files, thin disks, let's say, on VMFS 6, typically start off, you allocate a sub-block. When you've gone outside the size of the sub-block, we'll allocate a file block. And that small file block size is 1 meg. So that's how a thin disk will grow on VMFS 6. What's more interesting is this internal large file block. So now as you're creating thick disks, whether they're eager zero thick or lazy zero thick, we have this 512 meg large file block for allocating these files in advance. So what it means is it just speeds up the creation of these thick disks. Now you might think to yourself, well, I only use thin disks, so this isn't applicable to me. Well, in fact, it will, because when swap space is created as you power on a VM, the swap is always thick. So the nature of having this large file block should mean that the power on of VMs should be much quicker now on VMFS 6. Okay, so that's the first thing. The next thing then is the system resource files. So when we formatted VMFS previously, we would get a set number of inodes or file descriptors, a set number of sub-blocks, pointer blocks, and file blocks themselves. So all of that metadata that's associated with the file system was always static. What we've done with VMFS 6 is we've made this dynamic now. So when you first format a VMFS 6, you'll get a certain number of resources to allow you to create files. But then as you consume those resources, we'll allocate more resources. So now theoretically, we can have millions of files on VMFS as opposed to the tens of thousands that we've been limited to so far. Okay, so a little bit of future-proofing here as well, I guess. Okay. So this is just, there's a command vmkfs tools, I don't know if you're familiar with it or not, but you can display the layout of your VMFS using this. So this shows you the resources that are on the particular VMFS volume that you've created. So what I've done here is I've done a comparison between a VMFS 5 and a VMFS 6, and both of them are 500 gig in size. So in this one, just to highlight, this is VMFS 5, as you can see it there. It's still the 1 meg file block size. And we can see something like, let's take, for instance, the sub-blocks. So this is formatted with 32,000 sub-blocks. Let's have a look at a 500 gig VMFS 6. And we can see the version number there. It's still a 1 meg file block size, but now we have some new things in here, such as the large block, the large file block that I just mentioned previously. So we have this on VMFS 6. And the other things that are kind of interesting, we have less sub-blocks. So it's the same 500 gig volume, but now we have less resources pre-configured. So there's a couple of other interesting things here as well. There's no pointer blocks. So just what are pointer blocks? Well, essentially as you build files on VMFS, you get your file descriptor. Within the file descriptor, there's a bunch of pointers where you can point to the file blocks. But for large files, we need another level of indirection. So we'd have these file descriptors pointing to pointer blocks, which then point to the file blocks. And actually, there's a double level of indirection for the very large files. But what we've done is we've got rid of pointer blocks out of VMFS 6. Now we're using sub-blocks for the pointer blocks. So this is probably just, so we did say deep dive, right? Okay, but it's probably just something of interest if you're familiar with coming in here, looking at the VMKFS tools output, and you'll go, well, why have I got 0 pointer blocks? It's because we're now using sub-blocks for pointers in VMFS 6.
But this does solve an important problem that some people ran into, right? Is that if you exhausted your pointer blocks, right, and you could do that before you exhausted the capacity of VMFS, you could not create any more. You couldn't power on a VM. You couldn't add another VM, and it would say out of capacity. If you're like, hey, this is a 64 terabyte volume, I got 40 terabytes left. So if that happened to you, that's generally what it is. You ran out of pointer blocks, and so that being removed helps in that situation. Because I do see a lot more customers using larger and larger data stores, especially in the AFA world, where there's a lot more concurrency. Right? And so this solves a pretty important problem that they ran into with VMFS 5.
Excellent. Cool. All right. So another change we've made, and this is to do with journaling. So VMFS is a journal file system. In other words, we put an entry into the journal to say we want to do something with the metadata of a particular file. And this is just a way, in case there's a crash, we can go back and another host can examine the journal and figure out whether what that host intended to do actually got carried out on the metadata. So journaling plays a very important role on VMFS. It has to for distributed file systems of this nature. But there was a little bit of a problem with this that we've now addressed with VMFS 6. The fact is that the journal mechanism just used standard file blocks. That became an issue if you filled the file system, okay? Okay, I've filled the file system. I know what I'll do. I'll just delete some files. Well, in order to delete those files, you got to place your intent into the journal to say, I want to remove this file, so I need to update this metadata. But because the journal was using file blocks and there was no space left on the device, we had you jumping through hoops to disable the journaling mechanism in order to do that. So what we've done is we've shifted all the journal blocks into a resource of its own. So now it doesn't share standard file blocks. It's got its own set of resources. So even if we run into this situation where we fill the file system, we can now just manually delete files and clean up space. Okay, so that's a big improvement. Does that make sense? Yeah. And just to show you that I'm not lying, this is the list of system files here, or system resource files. The top one is the VMFS 5 list. So you have your file descriptor resource files. So these are in the topmost folder of every VMFS volume. You'll get these list of system files. They're hidden with the dot, but you can list them out. So you have your file descriptor list, your sub-blocks, your pointer blocks, and everything else that you have for your system resources. VMFS 6, we now have a new resource. That's the journal one there. So if you're curious as to what that is, that's what it is. Okay. Okay, this is a very interesting one as well. So how we, let's say, so typically when we were building VMs or creating files in VMFS, a host would be given a resource cluster or resource group, essentially a set of resources, okay? And that host could then create VMs and consume those inodes and sub-blocks and file blocks and so on. And so we had this thing which we refer to as a sort of host affinity for these resource clusters. So we tend to just give them to hosts. Say, oh, a host wants to create files, here's a resource cluster. Another host is sharing the same volume, here's your resource cluster. So that was absolutely wonderful. Not really much contention until you used vMotion. And then you started vMotioning VMs between the different hosts, or DRS kicked in and started migrating VMs around the place. So now you had multiple hosts sharing the same resource cluster or resource group. And for the most part, it's fine. But the problem is contention could arise if two separate hosts, two different VMs, consuming the same resource cluster wanted to do something at the same time, such as grow the VMs or modify the VMs or do anything. There could be a situation where there could be contention arise for the resources within the same resource cluster. So what we've now done is we've moved away from the host affinity approach to a VM affinity approach for these resource clusters. And so as you create, or as we create new VMs on the VMFS, we now look at all the available resource clusters and we look for ones that are not in use. So every new VM that's instantiated on the VMFS 6 volume will be given its own resource cluster. So now even if the VM is moved around and migrated, doesn't matter. Typically, it'll be only that VM using those resources, so there won't be any more contention. Now, of course, we could run out of all resource clusters, so we could actually end up with lots and lots of VMs and VMs having to share resource clusters once more. But what we do now is we look at the reference count of how many different files and VMs are using the same resource cluster, and we'll pick the one with the least number of uses, or least number of files or VMs using it. So hopefully we're again addressing situations where contention could arise when sharing resource clusters. Is that okay? Good, okay. This is probably the biggest improvement, okay? Many of you here use Site Recovery Manager? Okay, a few of you, okay. So this will be definitely a lot of interest for those of you who do failovers, DR, that kind of thing. The problem we've had in the past is that any sort of discovery operation, file system probing, when you go discover new LUNs, discover new file systems, that was a sequential process on a host basis. So we could have lots of hosts doing it at the same time, but within the host itself, that process was very iterative, very sequential in nature. What we have now in VMFS 6 is the ability to do this parallel. And I guess this is more of a vSphere 6.5 feature as opposed to a VMFS 6 feature, but we have the ability to concurrently discover lots of devices. So you have a demo coming up next, which will really show you, the scale of improvements with this new feature, the ability to do this discovery process concurrently rather than manually. So I think there might be just one more thing to come up, and then we'll jump into the demos. So this is kind of something that's close to my heart. It's been a pet peeve with a long time. If you had a 2 terabyte VMDK and you wanted to extend it, or in fact, if you had a VMDK that was greater than 2 terabytes and you wanted to grow it, you could not do that online. You had to power off the VM, which is a pain. So we finally fixed that as well, and now we can, hey. Excellent, yeah. So yeah, I mean, it's been a bugbear of mine, so yeah. And so this isn't VMFS 6 either. This is 6.5, so even if it's on a VMFS 5, you can do that as well. So after that round of applause, I do have to kind of bring it down a notch. There's no upgrade from VMFS 5 to VMFS 6. The problem is that the changes are so great that they're completely different file systems now. And I know we've tried to do this in the past with earlier versions of VMFS. I think when we tried to upgrade to VMFS 3, you remember we tried to use some space on the VMFS volume to start moving stuff around. And oh my God, enough said about that. So I think it's just that these file systems are so different that there wasn't really that option to do the upgrade. So I guess you have to look at this as kind of a net new file system that we're creating here. And so it will need net new LUNs formatted with VMFS 6. And so use something like storage vMotion, free up some of your LUNs that you have, and then rebuild VMFS 6 I guess is the approach to take.
I don't work for VMware, he does, so.
All right, so we're going to do our first demo, and this is the concurrency one, I guess.
Yep. Cool. Do a live demo. Start the video. All right. So essentially what this demonstration is showing is concurrency of resignaturing, right? I'm kicking off a script here to basically just resignature a whole bunch of volumes using ESX 6.0. And I've seen resignatures take hours for customers when they're trying to resignature a lot. And in these kind of environments, we're doing a lot of DevOps, right? Doing a lot of array-based snapshotting, bringing up the VMFS volumes, right? It can take a long time if you're trying to do it at once, because this resignaturing process used to be a very serialized process, right? One at a time, wait, and they'll sit there and they will all hang until they're all kind of done and figured out. right? So I'm kicking off a resignature of 8 VMFS volumes here in 6.0. And I will use some time lapse here because we're not going to sit here for 10 minutes and watch this, as fun as that might be. And we'll move forward here in a second to watch it complete, right? And this is actually a good example of resignaturing in 6.0 with a lot of volumes at once. I've seen it take 40, 50 minutes. This one took, I believe, about 5 or 6 minutes to do all of those, right? Which is not great, but it's actually pretty good. I picked a bad example, frankly, but still took a decent amount of time. All right, so I'm going to repeat this test, kicking off resignaturing with 8 volumes using 6.5, right? These are also VMFS 5 volumes. As I said, as he mentioned earlier, this is an improvement in ESX itself around locking and management of VMFS 6 volumes. Right? And so this can be done in parallel. So once again, I'm calling the same SDK call for resignaturing a bunch of volumes at once using just ESX CLI, right, inside of Power CLI. And we'll kick off the process once again here. So it's taking all 8 snapshots I have, looking at them, and it's going to do the resignature on all of them at once. Let's see, it's running. This takes 10, 20 minutes, 30 minutes? What do you think? A little bit longer, a little bit longer. And this is, once again, this is actually also a bad example. I've seen it take about 8 to 10 seconds. I think it ends up taking about 20 seconds here to do resignaturing, right? And so at scale, and this is, once again, this is one host, right? So if you spread these across more, it's going to even kind of get even better, right? So this resignaturing bottleneck that a lot run when they're spinning up a lot of different volumes at once will go away in 6.5. So you can really spin up a lot of concurrency when you're copying these data stores and so forth.
And I would say that it's one of the biggest complaints we have with the Site Recovery Manager product is that the amount of time taken for this whole resignature process can be a bit painful.
Yeah, I mean, especially with SRM, when you're doing DR, you want your DR to finish as fast as possible, right? And if you're waiting 45 minutes to resignature a bunch of volumes, that's not a good thing for your RTO, right? So the rescan's complete and the video's done. All right, VAAI, that's also me, right?
Okay.
All right.
So just before you go there, so what was that? You saw a 10-fold increase?
Yeah, it was about a 10-fold increase. It took about, I think it was like 26 seconds or something like that for resignaturing compared to 5 minutes. And that's, once again, a good example. I mean, a good example for 6.0, right? So you should be able to get better results than that. Okay, so let's move on to VAAI and some of the changes we've done. They've done in, who do I work for? In VAAI. So atomic test and set, compare and swap, hardware-assisted locking, it has many names. This is one of the most important VAAI features, in my opinion, out there, right? This is really unlocks the scalability of VMFS, right? This is what allows it to be huge and many VMs and many hosts. And one of the use cases of ATS, besides just kind of, reserving volume when you're updating metadata for VMs and things like that, is heartbeating, right? In 5.5 Update 2, they introduced heartbeating control of data stores using atomic test and set. Right? And so every host kind of updates its own heartbeat region, right? So the other host can know what's going on. Is this host still alive from if you're using VMware HA and things like that to know, is it still active, is it still using it, or should I and can I reset its locks, right? And using atomic test and set instead of traditional like SCSI reservations, once again, is a good thing, right? SCSI reservations lock out I/O. And so this allows you to lock just very specific regions, and it opens up for performance use cases and so forth. So there's a couple different kind of forms in 5.5 that it'll use for the heartbeating mechanisms, right? Acquiring a heartbeat, clearing it, replaying, reclaiming it. And so it really removes, once again, that SCSI reservation limit around managing VMFS heartbeating and liveliness of their actual hosts. And the reason I bring all this up, right, is a issue that I'm sure some of you probably ran into when it came to what referred to as ATS miscompare. Right, so essentially, when ESX is checking for these heartbeats, every so often, it might get a miscompare from the underlying host. It basically says there's 2 parts of it. There's like a test and set operation, right? And essentially, it sends a test and set and compares it. Hey, is this the same from last time or is it different? If it's different, then it's like, oh, something went wrong here, and ESX will tear down the storage stack on that host, right? It'll kind of abort all its outstanding IOs, and it'll bring the storage down for that host. The problem here is that often that miscompare was invalid, right? And there are a couple reasons for this.
The array, right? It was an array side problem.
What?
Array
all
side problem.
array problems, yes, absolutely. It's only array. But it's half true. Yep, your hair is beautiful today, by the way. We lost my train of thought. Talk about ATS. All right. If the VMware itself had too low of a timeout for some of these heartbeat commands, so it would issue the heartbeat, and then the array might take a long time to respond, and VMware would issue another one, but it would be the same, but actually the I/O got committed, and then it would look at it, and it was all confused, and it would tear down the stack, right? Sometimes if the arrays were overloaded, it would just return a miscompare, right? Once again, tearing down the stack. And then sometimes it would just return a miscompare. And often, pretty much in all these situations, it was a false miscompare, right? And so ES6 would tear down the storage stack for really no reason. So there's a couple improvements that have been put into this. One is increasing that timeout, right? So that doesn't happen. Also, if they get a miscompare, they'll actually verify and read the data on the heartbeat to say, is this actually a miscompare? Or is it some false return, right? And so if it sees, oh no, this wasn't, we'll move on, things will be fine, right? They'll also do some retries as well around reattempting ATS heartbeating. So most of the time, it's a false miscompare. And so those situations you ran into where that would happen, that should go away in 6.5. So I said there's been enhancements from a VMware layer to handle it better, and I know some array vendors that ran into that problem also did fix it from an array side.
Yeah. I think it's fair to say that there was kind of issues on both sides of the fence. So some arrays didn't handle this very good, and there were certain situations where we didn't do a good job either. In fact, there were situations where the host bus adapter was the root cause of an ATS miscompare, so go figure on that one. But I think this is a great improvement.
That's the situation where the storage vendor and VMware figured out the root cause. It's the HBA.
There you go. It was all a HBA issue, yeah.
All right, so this is a topic that's somewhat near and dear to my heart, UNMAP. I talk about it a lot, but it's very important. So if you're not familiar with the concept, UNMAP is used for dead space. And dead space is, hey, when you delete a VM or a virtual disk on a data store, or you move one to another one, the underlying storage array hosting VMFS does not know that that space has been reclaimed. So it will store it until it's told otherwise, right? UNMAP is a function to tell it otherwise, saying, hey, these logical block addresses, I don't need it, reclaim them. Do what it is that matters, right? Zero it out or deallocate the metadata, whatever your array wants to do with it. And so introducing UNMAP into VMware has been a journey over the past couple of years. It was originally introduced in 5.0, and it's been bounced around in various forms ever since. There's been a lot of work done in UNMAP in 6.5, really important work. So let's take a look at what some of this is. So automatic UNMAP is back for VMFS. This is a very important one. So now, when you delete VMs, when you delete virtual disks, when you move them, VMware will run a UNMAP crawler. The 6.5 host will run an UNMAP crawler to that VMFS 6 data store to asynchronously reclaim the space. Right, so they'll coordinate with one another to make sure that that capacity is returned on the array. So you don't have to run a CLI command. You don't have to run scripts or whatever to reclaim the space on VMFS 6. There is an important requirement. It requires 1 meg granularity of UNMAP alignment on the array. Right, UNMAP or 1 meg block size essentially on the array you're issuing the UNMAP to. So check the VMware HCL for support for automatic UNMAP of your array. And Cormac wrote a good blog post explaining the ins and outs of that as well. A couple things to note about it. It is turned on by default. Right? So if you create a VMFS 6 volume, automatic UNMAP is enabled. It can take a while. It can take a day, half a day to reclaim that space, but rest assured it is happening. There is a way to monitor it using vSISH to see, like, is this host actually issuing UNMAPs and things like that. You can enable or disable a given host from participating in this automatic UNMAP if you want to. This is a CLI option, enable VMFS 6 UNMAP, so you can turn it off if you want to for some reason. Important thing to note, if a given host does not have an active world on that data store, meaning a VM that's essentially running, it will not participate in UNMAP. It will ignore that volume entirely. So for automatic UNMAP to work, you have to have at least one VM running somewhere, right, on a 6.5 host. So I've had some customers where they just basically, they had a bunch of powered down VMs, it wasn't being reclaimed, right? So that's something you want to check. One more note about it is that there are 2 settings for it, on and low. There are some blogs out there, and there's even the internal CLI even reports medium and high. That is a lie. It is on and low. Those are the 2 options for enabling this, but low works quite well.
Yeah, we might use those medium and high at some point in the future.
Yes, of course. But that's, who knows?
Future looking.
Future stuff. OK, so in-guest UNMAP. That's VMFS. That's when you delete a VM or move a VM off of a data store. But what about in the guest? Right, there's another layer of kind of virtual SCSI virtualization, right, to get to that guest. If you delete a file in your VM, if you move a file in your VM, VMFS doesn't know, and neither does the underlying array, so dead space. And so in 6.0, there were some improvements in the stack to be able to have the guest issue unmap down to the underlying data store. So essentially what happens is that if there's dead space in that VM, if it's a thin virtual disk, only supported with thin, the thin virtual disk will shrink in accordance to the space that was reclaimed in the guest. And then ESX will issue unmap down to the array, right, to end-to-end unmap support. I found this particularly important in VDI environments where people are just throwing all kinds of stuff inside of their VMs and deleting and moving around, right? And I've seen customers actually get 40% of their array back just enabling this functionality inside of their VDI builds, right? So it can be particularly important. So some considerations around here, right? I mentioned that it needs to be thin, right? If the guest also issues trim, that's also supported. Essentially, they convert it into unmap, the virtual SCSI layer. So in-guest trim will work as well. Main thing to note about 6.5 support is it added Linux support. In 6.0, VMware used an older SCSI version, SCSI 2, I believe. In 6.0, that basically Windows was the only OS that supported SCSI 2 unmap. Linux needs, I think, SCSI 5 or later. So in 6.5, they updated their core storage stack internally to support up to SCSI 6, SBC 4. Right? So now Linux in-guest unmap works, and it works very well. Windows, there's been some hit or miss with in-guest unmap because of some alignment issues internally, but Linux works very, very, very well inside, and that was the main change in 6.5. Another thing about 6.5 is that in 6.0, in-guest unmap did not work if change block tracking was enabled. That also goes away in 6.5, so it works with CBT turned on, which is probably a good thing for a lot of you. So I did mention there is some file system alignment requirements internally. Linux, generally by default, the file systems will work out of the box with in-guest unmap, ext4, XFS. I've actually never had to tune any of them if you use a standard file system, but they do need to be aligned on. The unmaps themselves need to be aligned to 1 meg boundaries, right? So making sure your file system, of course, is properly aligned is important. Windows sometimes listens to alignment requests from VMware. VMware is telling them to do the right thing. If you allocate your NCFS using the 64K or 32K allocation unit size, it seems to be more efficient with its unmaps. So that does seem to help. And 64, I believe, is the best practice for SQL, so that happens a lot. But there has been some help, some work along this after 6.5.
The journey continues.
The journey continues. Hair looks great. All right, I'm done. All right. So in 6.5, there was initially some alignment issues, right? So if the guest issued misaligned unmaps, VMware would reject them, right? So nothing would happen down the stack. So in 6.5 patch 1, they introduced a feature that basically, all right, whatever of these unmaps is aligned, I'll take. What is misaligned, I'm just going to zero out, right, inside the VMDK. The benefit there, if you have like a data reducing array that just removes zeros, then that's the same as unmap. And pretty much every other array also has zero space reclamation procedures you can run. So that pretty much allows misaligned unmaps to work through to through. Of course, there was a performance issue with that, which is fixed in 6.5 update 1, where they handled the misaligned unmap much better. So that problem does go away. So I know it did crop up in Windows systems. All righty. So I'll do another live demo, start the video. So this is going to be of in-guest unmap, right, how it works inside of Linux. So I have an Ubuntu VM, and I have just kind of an empty virtual disk. There's like 400 megs have been written by just creating the file system inside of my Linux virtual machine. So I'm going to copy over some files just into my Linux VM. I'm a Windows user, I'm sorry. But at least I did do a Linux demo, so it's halfway there. And so the VMDK is going to be much larger. I copied over a couple ISOs, VRA, and things like that. We'll refresh it, and I think it's about 4 gigs in size. And so my thin VMDK has grown on that VMFS to use all that space. And if we look on the array itself, and I look at my capacity on it, you can see I have capacity also written to the array. Now, since it's a data reducing array, it's less than the 4 gigs, but there's still capacity written down to the array itself. So we want to reclaim it in both these spots if we delete these files, which is what we're about to do, right? So I'm go here, and I'm going to take a look at my internal file system first. We'll see what's free inside of the guest. Right, so I'll look at my mount here for my file system here. I'm using 4 gigs, just like that VMDK reports, the 4 plus the 400 meg for the usage. Now I deleted it, and I'll run it again. Now my file system is cleared up, right? It's not using anything really, 44 megs, just for some metadata and so forth. So I'm going to run fstrim. This is the manual unmap procedure inside of Linux. You can also mount your file system with the discard option. It'll automatically do it when you delete files. So either manual or using the automatic one. So it'll tell you how much it trimmed. I'll refresh it here. my VM decay is back down to that 400 meg. And then if we jump back to my array, we'll see the capacity has been reclaimed as well. So zoom in a little bit on this volume. We'll look at my capacity, and bam, it's back down to 0. Right? So this works quite well with Linux. So if you have capacity on your array that you're like, why is this being written? My guests aren't reporting it. It's probably this reason, and this works quite well in 6.5. So another major reason to move to 6.5. Cool. All right. And all my demos are working today.
Very
so
nice
awesome.
one. Great. OK. So I'm going to talk about storage policy-based management, but I'm not going to talk about it, obviously, in the context of vSAN or virtual volumes, which also uses SPBM. But we're going to talk about I/O filters, or VIO, as it was also called, vSphere APIs for I/O filters. So within 6.5, we have 2 I/O filters that now come with the product. So again, I/O filters, just by way of explanation, I/O filters are a way of plugging into the virtual machine I/O path and providing data services. And so the I/O filters we're going to look at are 2 data services that we're providing from the ESXi hosts. So as I said, SPBM, it's been around for a while. We use it a lot in vSAN. We use it considerably in vVols. They're basically, cornerstones of both of those products, and I guess it's cornerstone of the SDDC or SDS, the software-defined storage. But we can also use it with VMFS as well. In fact, the first iteration we had of this was all to do with VMFS and discovering, capabilities that were associated with a particular volume. So how we consume it is quite straightforward. You just build a policy that says, I want a particular data service to be on or off or set to a particular value. So it could be, I want to put my VM onto storage that provides deduplication, but maybe does not provide encryption, or provides me with availability that's done as a RAID 5 or a RAID 6, or something like that. And then what you can do is you can group these bunches of rules together to make a rule set. The rule set gets saved, and then when it comes to provisioning time, you just pick the particular policy that contains the rule set you created. So it's quite straightforward. So for those of you who've done policies before, you're probably familiar with this screen. For those of you who haven't seen it, it's simply a way, this is the wizard that we pop up to create a particular policy. So there's lots of interesting information in here, which most of us just whiz past and don't read. So I just want to highlight a couple of things. There's the common rules section here. So most of us are probably familiar with using storage policy-based management for array or HCI type data services, but this is where you can select host-based data services. So here are the common rules. This would be the VIO, the I/O filter section, and down here you would have the, further down, you would have the VMFS, vSAN, vVols, and so on. So we're going to concentrate on the common rules, which is how we can provide data services to our virtual machines, okay, using I/O filters. Okay. So we shipped 6.5 with 2 of these I/O filters. The first one is VM encryption, and the second one is storage I/O control version 2. Out of curiosity, are there many of you using storage I/O control? Quite a few of you. Okay, good. So this is, again, going back into that wizard. We're just after progressing to the next screen of that wizard, and this is where you can select the common rules for host-based data services. And from here, you can select encryption or storage I/O control. So this is a look at just storage I/O control. What's really nice about using I/O filters for storage I/O control is you don't have to go around to every single virtual machine and add those attributes that you've done before, whether it's IOPS limits or reservations or shares. You can now just set up this policy around storage I/O control, and you can apply that policy to very many virtual machines at the same time. Or if you're provisioning new virtual machines, you can select it at the provisioning time as well. So you don't have to go and manage lots of different VMs manually. You can do this through policy and almost automate the whole setup of storage I/O control. The one thing I do want to mention as well is that although we're providing 2 of these I/O filters with vSphere 6.5, we also have partners who are developing I/O filters as well. And right now, the common one seems to be the cache acceleration. So if you wanted your VMs to use local SSD or maybe local NVMe or even maybe a portion of memory, some of our partners have developed cache acceleration plugins that would just fit in here as well. And you would set it up exactly the same way. It would be a common rule, and you would select that cache acceleration I/O filter at this point. But in this case, we're just looking at the storage I/O controller, the VM encryption ones. I expect over time that we'll see more and more partners develop more host-based data services as well. It's just for the moment, we just seem to have the cache acceleration ones available. Okay.
So one thing I wanted to say, actually, there's
sure.
kind of an interesting use case I've seen some customers use with 6.5 and the I/O filters around like VDI. Like they have like VDI deployments that, hey, this is sized for 25 IOPS a desktop. I want it to be that. Right? And using this with policies is a really great way to do that really fast. Because before it was kind of a manual each VM thing. Doing this with policies really helps, and it actually has your VDI environment do exactly what you sized it for on a per VM basis. So.
Cool. Yeah, so just from a VM encryption perspective, the one thing to note is you do need a key management server. So we do not provide that. So you will need to have a KMS from one of our partners. Again, you can check the HCL to see who's on our partner list there. And it's very straightforward. Again, it's just you build that policy and you associate the policy with the VM, and the VM's I/O is encrypted. So not just at base, but also in flight. Okay. And so both of these are now policy-driven, storage I/O control and encryption. Yeah, and just I think it's just showing you the how you can select it. There's no options really here other than if you had multiple I/O filters, you could organize the I/O filters where they appear in the I/O path. So do I do encryption before storage I/O control and cache acceleration perhaps? And it's just a way of reordering them within the I/O filter path. So I think there's a demonstration here now as well. And it's just very quickly just showing you the setup of storage I/O control to show you how simply you can do this with, if we could just roll the demo. Yeah. So yeah, it's just really to show you, in this case, you do need a VASA provider for this, but it comes automatically with the ESXi hosts. So now I'm just going to go into the VM storage policies. You can see there's some pre-canned policies in here already, but I'm going to build a new demo policy. And my demo policy is going to utilize one of the host-based I/O filters. So I'm going to do the common rules here, and I'm going to do storage I/O control. So I can look at the different options that are available in storage I/O control. You can see that there's canned limits, reservations, and shares, but you can go in and customize these as well, just like you can with storage I/O control today. So I'm just going to set up my first one. I can also associate this directly with some storage if I wished, or I can actually leave the storage part out of this. The one thing to note as well, this feature only works with NFS and VMFS. It does not work with vSAN and vVols at this time. So now that my policy is created, it's just a matter of creating a VM and attaching the policy to the VM at provisioning time. Now, we could also attach it if the VM is already created, but it's just to show you that you can do this at provisioning time as well. So at the point where I get to select the storage, there you can see I can just select my new policy demo that I created, and I can just provision my VM onto any of those NFS or VMFS data stores that I have available, and it has storage I/O control configuration in place already. So it's going to speed things up dramatically if you're moving from storage I/O control version 1 to version 2. And if you have storage I/O control version 1 already in place, you can build these policies with storage I/O control version 2, and they will override your storage I/O control version 1 configuration. Okay, so I'm going to move on. NFS 4.1 improvements very quickly. First one is VAAI NAS primitives, basically the ability to offload certain tasks to the storage array. We can now do this with version 4.1 of NFS. Okay, so this is available in 6.5 as well. So we couldn't do this previously, but we can do that now. A few other things then, Kerberos support. So we added IPv6 support in vSphere 6.5 for NFS 4.1 Kerberos, and also AES encryption is supported as well. So for any of you using NFS version 4.1, anyone using it? A few of you? Okay, so these might be certainly of interest to you. iSCSI, just very quickly, another bugbear of mine that we've finally resolved is the ability to route iSCSI connections. So this is with port binding. And if you're familiar with that, it's a way of attaching the initiator to a particular adapter. If you didn't do port binding, you could route the iSCSI traffic. But our best practice was implement port binding and attach your initiator to adapter. Fortunately, the moment you did that, routing no longer worked. Okay, so we had, I don't know how many support calls to say, I've just done port binding and now I can't connect to my target. Oh yeah, yes, we can't route that traffic. So we can now. I have a funny feeling this might have been in previous versions of vSphere, but we didn't explicitly call it out as supported. We do now. And then for those of you using UEFI, we can now boot from iSCSI UEFI as well. All right, so that's short and sweet. And I think I'm going to just pass back to you to finish off.
All right, let's clear it up. So probably any storage booth you visit today will probably beat you over the head with a bat that says NVMe. So we're certainly going to talk about it here a little bit. And it really is an important thing moving forward from concurrency reasons and parallelism and so forth. But VMware has started down this path as well, right? So inside the guest today, you're probably using LSI Logic, virtual SCSI adapters, or para-virtual SCSI for higher performance levels. In 6.5, they introduced the NVMe device. Right, so this allows an NVMe controller instead of a SCSI controller inside of your VM to access your storage. Right? And there's a variety of reasons that you might want to use this, and there's a lot of them around parallelization. Right? If you have local NVMe drives inside of your host, you can get some pretty significant performance benefits using them. Now, moving forward, right, the full NVMe, NVMF stacks, or RDM, all that kind of stuff is coming further down the line from the array vendors and VMware and so forth like that. But this is the first very important step, at least internally in the host, leverage that NVMe. Right? So there's some performance benefits around it. As far as kind of a scalability perspective, it's very similar to all the other ones from a para-virtual, from a virtual disk numbers and things like that. Right? How many virtual disks you can have per controller, the queue depth limits, pretty much similar to what para-virtual can do as well. Actually, overall, NVMe is a little bit higher than para-virtual, so you get some better performance here. The one thing I do want to note is that NVMe is a protocol, right? It's not a physical connectivity kind of thing, right? And so the UNMAP inside of it is different, right? It's called deallocate inside of the NVMe spec. Right? That's not supported today. So if you're trying to do ingest UNMAP and you have the NVMe adapter, it's not going to work, right? But it's certainly something to keep an eye on as we move forward in the whole NVMe journey, whatever word you want to look at. All right. I think that does it.
Yeah, so we have 10 minutes for Q&A. I believe there's microphones in the aisles, so feel free to come up and ask us a question. And thank you very much.